So, welcome to this session. In this session, we will discuss the remaining portions in pointers. So, we are going to see character pointer and strings, pointer of structure or a structure to a pointer, then self-referential structure. These are the three things that we are going to discuss today. So the first one is character pointer. So we have seen integer pointer, then floating point pointer, how they are declared, etc. We know a pointer variable can be declared using its data type. If it is integer, int, then followed by a star, then a variable, say p. So this will create a pointer p, which can store address of memory location of type integer. Now we shall see how character pointer can be used to handle strings. We know in C++ we used to use character array for handling strings. Something like this. Char, say name of say 15. And if you write a statement like this, scene name. This statement can be used to read or input or take accept or to accept input through keyboard to this variable name. Here when we create an array like this, what happens? It will allocate 15 bytes in memory. This is static memory allocation. The name of entire array is name itself. This is name. And we have zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are bytes. These are contiguous memory locations. Contiguous memory locations. In RAM, suppose address of this first byte is 1000. This will be 1001. This is 1002 and so on. We know that an array name itself is a pointer, so this will point to this area, which means this contains 1000. And suppose we are inputting a name, James, say James. What happens? J, A, M, E, S will be stored like this. And the last character will be the null character, showing the end of the string. So this is the way of handling, the way that we used for handling strings. Now we know this area, this space, this location is, this can be accessed using name of 0. Name of 0 means J. Name of 1, this is name of 1. Name of 1. It is A. So this name itself is a pointer. So while using this array for handling string, it has some limitation. The first one is See, suppose we have reserved here 15 bytes, but the name is James, it uses only 5 plus 1, 6 bytes. The remaining 9 bytes are wasted. So there is chance for wastage of memory. And suppose a larger name which contains more than 15 letters is inputted. What happens? That name will be truncated. So there is sometimes insufficiency of memory as well as there is chance for wastage of memory. So if you are using character pointer for handling strings, we can use character pointer for handling strings. So these limitations can be, we can overcome these limitations. How we will make use of character pointer? We can create a character pointer like this, cap star str. It's a pointer. So what happens in memory? It will create a variable that can hold address of memory location. What kind of memory location? Address of a character type data memory location. Now suppose we are writing a statement like this. str equal to name. str equal to name. What happens? Say suppose this is the memory allocation for name and this is the content. We have written str equal to name, which means this will be 1000 will be copied to this. So what does it mean? This also points this. Now we can write statement like this. Cout str. This will print. This will give you output James. Now what is Cout star str? What will be the output of Cout star str? Which means value at str. So previously in the case of integer array and floating point array, we are creating an integer array like int star ptr, and we have a variable like this in the a equal to 10, and we are making a statement like this ptr equal to ampersand a. What happens? Address of a. We know this is a. It has some address like this 500, 501, and so on. 503. 4 bytes are used. This contains 10. Address of this a is 500. So ptr equal to address of a gives, this is ptr, and address of a is 500. This points this. Now here, in this case, if you are writing a statement like this, Cout star ptr, this will output, this will give out 10 output. And Cout ptr will print this 500. It will print 500 address. See here, this is the way of how actually the pointer reacted. In this case, if you are writing a statement like this, Cout str, it is similar to that. Str is a pointer here, ptr is a pointer, this is an integer pointer, this is a character pointer. Here Cout ptr prints the address, content of that ptr. But here Cout str, This is also character point. This is a character pointer. Cout str prints the content of the array or memory location that James will be printed. So the way of reaction, how they execute is different. The operation is different. Cout star str. Cout star str give you value at str, value at 1000. It will give you j. Cout star str plus 1. This will give you a. So in this way, we can use character pointer for handling strings. Now let us see another example. Char star ptr equal to hello. So what happens? We have a ptr. We have hello h e l l o slash. In this way, the memory is allocated. Suppose this is 1000, this is 1001, and so on. This ptr contains 1000. This key point is. And if you write a statement like this, cout ptr, output will be, what will be the output? Hello. Cout star ptr, output will be h. Cout ptr plus 1. Cout ptr plus 1 without any star. Cout ptr plus 1. The output will be hello, starting from the second character hello. Then cout star ptr plus 1, output will be e. So this is the way how we can manipulate strings using character pointer. Now we can make an array of character pointers for handling a set of strings. How? Char star list of say 4 equal to Raj Ali James Rita. So star list of 4 is a pointer array having size 4. So it will create an array like this. This is the array. It has 1, 2, 3, 4 locations. Name of this is list. This is list of 0. This is list of 1. This is list of 2. This is list of 3. Now on initialization, what happens? This will create ARA dash, something like this. This will create another for 3 bytes ID like this. And here another JAMES, another set of bytes. Here another set of bytes RIE. Suppose the base address of these 4 bytes, say 500. Let this be 550. This is say 600. Say this is 750. And so here this contains 500. So this points this. This contains 550. This points this. This contains 600. This points this. Here contains 750. This points this. In this way, we can handle a set of strings. Now, if you write a statement like this, see out list of 0, the output will be Raj. If you write a statement like this, see out list of 2, what will be the output? It is James. So, in this way, we can handle a list of strings using character pointer array. Now, what are the advantages of using character pointer array over, character pointer for handling strings over character array? Here, if we use character pointer, there is no insufficiency of memory or wastage of memory. If you use character pointer, if you are using character pointer for handling strings, there is no insufficiency of memory or wastage of memory. This is one of the advantages. In the case of character array, we have seen that earlier, there is chance for wastage of memory or sometimes insufficiency of memory. Then equal to, say, assignment operator. Assignment operator can be used to copy a string. In order to copy the content of a variable to another variable, we can use this equal to operator. But in the case of arrays, in the case of character array, we used strcpy function. We used this function. So here there is, if you are using character pointer, there is no use of strcpy to copy a string from one to another. Then the elements in the strings or characters can be accessed using pointer arithmetic. So we can perform pointer arithmetic and each and every character can be easily accessed. This makes the concept of character pointer easy for handling strings. Now the next is pointer of structure. Pointer of structure. We know a pointer has its type, as we seen char star p, which means p is a pointer of type character. This is a built-in data type, fundamental data type. Int star p, in this case p is pointer of type integer. Shorting star p, in this case p is of type pointer. Shorting float star p, here p is of type float. Now suppose we have created a structure, say something like this, struct, say employee. INT EMP code. Char name of 20 and float salary. This is a structure. We can create a variable of this employee EMP. This is a variable. EMP is a variable of type employee. Now we can create pointer of this type, pointer of employee type. How we can create? The way is employee star PTR. Here this PTR is of type employee. Now this PTR can store address of memory location reserved for employee type variable. So here employee EMP. What happens when we create a variable like this? It will reserve some space, say EMP. It has employee code, name and salary. It has EMP code, name and salary. Now suppose the starting address of this entire EMP structure, let it be 1000. And we are writing a statement like this, PTR equal to ampersand EMP. We are writing a statement like this, PTR equal to ampersand EMP. What happens? Here we have PTR, this contains this 1000, so this points this. So in this way, we can create pointers to structures. Now if we allocate memory for a structure in dynamic fashion, now we shall see how memory for a structure can be dynamically allocated. We have structure EMP here, employee here, and now we are creating a pointer, employee star PTR. So PTR is a pointer of type employee. Now we are making a statement like this, PTR equal to new employee. So we are using new operator here, which means we are allocating memory for this employee type using dynamic memory allocation. What happens? It will allocate some space, some bytes. How many bytes? 4 for integer, then 20 for this array, and again 4 for this. So 420 plus 4 plus 28 bytes. A total of 28 bytes will be reserved from the heap area, and it has different parts like this. This 4 bytes, this is 20 bytes, this is again 4 bytes. Now suppose the starting address of this is say 4000. Starting address of this entire area is 4000. That 4000 will be stored inside PTR. So this PTR points to this area. Now this part is EMP code, this is name, and this is salary. We know we used to use dot operator for accessing different elements in a structure. But here, if we are using the concept of pointers, we cannot write a statement like this: ptr dot emp code. We cannot write ptr dot name. So while we are using a pointer to a structure, we cannot use dot operator for accessing structure elements. There comes an answer: arrow operator. The operator used for accessing structure elements when we use pointers to allocate dynamic memory allocation and pointers to allocate structure memory area, and for accessing, in that case, for accessing structure elements, we make use of arrow operator. Arrow operator. Arrow operator is used for accessing structure elements when we use pointers. With the help of pointers, if you are accessing structure elements with the help of pointers, or we are handling structures with the help of pointers, for accessing structure elements, we will make use of arrow operator. What is an arrow operator? An arrow operator is something like this: a hyphen and a greater than symbol. This is called arrow operator. A hyphen and arrow operator. So instead of this dot operator, with the concept of pointers, we make use of arrow operator to access structure elements. So for accessing this EMP code, we have to write statement like this: ptr arrow EMP code. For accessing this name, you have to write ptr arrow name. So for inputting value to this, we can write C in PTR. For output, C out PTR. So this is the use of arrow operator. Now, one more thing is the self-referential structure. Self-referential structure. Self-referential structure. A self-referential structure is a structure that contains a pointer of same structure as its element. If a structure contains a pointer of the same structure as its element, at least one, it is called a self-referential structure. Let us see an example. We are creating a structure, struct, say data, or say usually use node, it would be node. Then we have say some int data available, float value, another variable. We know this is the definition for an ordinary structure. Now this structure becomes a self-referential structure if this structure contains a pointer of this structure as its one of the members. See, the structure's name is node, so node star ptr. So here, without this is an ordinary structure. If you are creating a pointer of this structure, that is node structure, node star ptr, this becomes a self-referential structure. So a structure that contains a pointer of same structure as its member is called a self-referential structure. This self-referential structure is a very important concept which is used for the creation of trees, graphs, linked lists, dynamic data structures, etc. So we represent a self-referential structure something like this. Usually it will be having two parts. Here we will store the data. The second part will be known as the linked part. Data part and linked part. This can store address of another same structure. Again, this is data and link. What does this link contain? Another structure having the same. So this contains the address of this part. Here contain data and link. So this is self-referential structure, a structure that contains a pointer of the same structure inside it as its element is called a self-referential structure. So this is all about pointers and self-referential structures. Thank you.